Hey everyone, in this video I want to show you how we can export a surface to a digital elevation model that we can then further process, for example, in a program like QGIS. If you want to follow along, then just open up the project files and open up the keyline DEM drawing that is under the storage module section 4.2. In this drawing we created a final surface for this dam that includes the dam, the channel, and any other auxiliary structures like the spillway. And we can preview the surface by expanding the surfaces section here under the tool space. And this is our final ground surface. So if you just right click on it and choose select, it's going to be selected in the viewport, and then you can right click and choose object viewer. And now I'm going to expand the object viewer and then just left click, hold and drag out to see the final surface. And if you release, it's going to give you a conceptual view. You just have to change the style here to something like conceptual, or you can also try one of the shaded ones. So here we can see just the spillway, channel, and the embankment, but apparently we haven't yet included the borrow pit here, so we can do that now. So I'm gonna exit out of the object viewer and then expand final ground, expand definition, and then go under edits. And I want to expand this section down here that lists all of the surfaces that are currently embedded inside of this surface. And we can see that the borrow pit is missing, so we need to add that. Before we do that, we need to remove the embankment because we want the embankment to be on top of the borrow pit. And like I explained in the video dealing with this, the way in which you stack these surfaces matters. So we want to stack them from the bottom up, the way we would do in the real world if we were to build this. So I'm going to right click on the embankment and choose to delete it, and then I'm going to right click on edits and choose to paste surface. And now we want to paste the borrow pit first, so I'm going to double click on that, then repeat this process and now paste the embankment on top. So we can see now the embankment is last, and we got a warning here saying the surface is out of date. So we just have to right click and choose to rebuild, and now we can right click, choose select, right click and object viewer again, and now we should see our borrow pit is reflected in the surface and everything looks correct. So this surface is now ready to export to a digital elevation model. So we can just exit out of the object viewer, and now to export the final ground we can right click on it and choose to export to DEM. From here under name we already have a name assigned and we already have the coordinate system assigned because this drawing has already been georeferenced. All we have to do now is to decide on the resolution of the DEM and where we want to save it to. So just click on this button here to the far right next to DEM file name, choose a location where you want to save it to, and now we have to also choose the file type. So we have two options. We can choose DEM or GeoTIFF. I would suggest use GeoTIFF if you can. It's the standard. And then I'll just leave it at final ground and click on save. Now for the resolution, this here is called grid spacing. So currently this is set to 1, which would be a 1 meter per pixel resolution, which is fine. If you want, you can make it higher by just reducing the number here. So if you set it to 0.5, this would effectively be 0.5 meters per pixel, and so on. So it depends on what resolution you want, but I would say don't go a resolution that is higher than what the original data was based on. So if the original data from which we created these contours is, let's say, 5 meters per pixel, and you set 1 meter per pixel here, then obviously you're now interpolating or guessing. And so it's a good practice to just sync in with your original data. And if your original data allows you for high resolution, then you have wiggle room. You can choose to go lower or higher up to the threshold of the resolution of the original data. In this case, I'm just going to leave this at 1 and press OK. This will export out the digital elevation model to that folder. Now I'm going to open up QGIS and open up that digital elevation model there just to do some quick processing, just for example's sake. So the digital elevation model is now finished processing and we can see it in the folder here. The file is actually really small, at just 3 megabytes. I'm gonna drag this and drop it into QGIS and we can see it here. And if you look closely, you will also see the dam has been reflected. Now notice that sometimes there is going to be missing data. So we have a few pixels here where there is no data. And before we run any processing on this DTM, it's good to fill in this no data. So I'm gonna select DEM go under raster analysis and choose to fill no data. You may leave everything here at default and just click on run, and now we can see a new layer was created and those missing pixels have been filled in. I'm gonna delete the original layers, we don't need it anymore, and I'm gonna call this DEM. Now we can run any kind of processing on this DEM just as we would normally. Let's say we want to create contours from this. We can go on the raster menu, extraction and contour, and we can do 1 meter interval, for example. And we can see those contours, they also should reflect the fact that there's a dam there and channels. Now notice that the resolution of the contour layer is not high enough to capture the full extent of our channel, so you would probably have to do something like 0.25 meters or so, but the rest of the dam looks okay. We can also do, for instance, a slope analysis, so we can go here under raster analysis and slope and just run the algorithm as it is by default, and then we can right click on the slope, go under properties, and we can go under symbology and switch the render type to single band pseudo color. And here you can define values for your slope. I'm gonna change the interpolation to discrete. We can add a few more values here just by clicking on the plus button down below. And let's say that we want to do every 5 degrees of step. Before I do that, I'm just gonna select a spectral band here just so it will apply the colors again. And I also want to invert it, so I'm going to choose invert color ramp, and I'm going to do the first one 5, then 10, 15, 20, 30, 35, and the last one we're going to leave it as it is. This will be anything above 35. I'm just going to change the color for this very first one, just make it a brighter blue or something, and click on apply, and this is our slope map for that. I think probably we're going to need more definition to the slope map just by adding more values, so we can better delineate the different slopes on here. But you can see the channel and the dam and the spillway are all captured. Again, you can just run any kind of processing on this DTM, and probably we're going to cover a lot more about this in the analysis module. So for now, I think this was just a very quick demonstration. Thank you for watching, and we're going to see you in the next session.